Calculus test, limits through motion. We had a test last Friday, and we're going to go over this test. Problem 1, determine the limit as h approaches 0 of all this on top over h. This is a basic definition of derivative problem. And the definition of derivative is simply f prime of x, the derivative is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And so what you're looking for, any place on a function that you see f of x plus h, that's like x. So here's x plus h. That's going to be like x. That's going to be like x to the fourth. Here we have x plus h. That's going to be 3x squared. Here we have x plus h. That's just going to be x. And then on the right side here, I'm circling in blue, is going to be the minus f of x if everything is right. These are just x's here, not f plus x. So our f prime of x is going to be this negative, this x plus h is just going to be negative x squared to the fourth power. It's not going to be f prime of x. I'm going to write, I want to get the language right, so I'm going to put this below. Okay, f of x is going to be negative x to the fourth power plus 3x plus h is going to be x squared plus x. And so to find f prime of x, we take the first derivative. So f prime of x is going to be negative 4x cubed plus 6x plus 1. This is going to be f prime of x. This is a basic definition of derivative problem. I am not going to let this go. Everyone needs to get this level of problem correct. Next, problems 2 through 6. I don't want to go over all these problems, but just point out a few things. One thing that I'm seeing that hurts a lot of people is the organization of this problem. Brianna organizes pretty well. Not a lot of others. I don't see a lot of other organization here. So let's see what we have here. That's the third power. Okay. Basically, on this one, 2, the main problem I saw is that a lot of people didn't take this negative times a negative, which ends up turning this sign here on the answer to positive. Some people got negative 15 over 2x to the fourth power. On number 3, again, we sort of had a negative sign problem. We have right here, I'll point this out. Yeah, this is a basic quotient rule problem. Well, what you have is you have low d high minus high d low. So everything here on the right, we're going to have 12x minus 12x cancel out sure enough. But this is going to be negative 3 minus 12. So you're going to end up with negative 15 in the numerator. And for this one, we had Mashavian and Alex get this right, but I think everyone else missed a sign change and ended up with the negative 3 plus 12. We get 9 in the numerator. All right, here we have numbers 4, 5, and 6. Class, you cannot distribute, for number 4, you cannot distribute through a binomial to the fourth power. And on number 5, you cannot distribute through a binomial to the third power or fourth power. And basically with 5, and most of these, it's a matter of organizing. If you organize your u and u prime, v and v prime, and just put it all together, we had a few who did really well on number 5. Number 6 was probably the one that most people did the best on overall. But again, organization. If the rewrite in calculus-friendly form right here, rewrite. And then once you get to the rewrite, it's going to be easier to see what's going on and to organize a correct answer. Anyway, problems 2 through 6 are bread and butter. You have to be able to get, I don't know if we had anybody get more than 3 out of those 5 right. Some people got 2 right. Some people got 5 right. We need to be better at this. All right, number 7, determine if the following function is differentiable at x equals -1. So for differentiability, we need to have first continuity. And so we're going to do the continuity test first, which is limit, as we're looking at -1, as x approaches -1 from the left side of f of x, it's going to be equal to the limit as x approaches the -1 from the right side of f of x. And I didn't mention it yet, but also we have to say f of -1 has to exist. Well, we know f of -1 exists because of this less than or equal to. That equal to here on the top, that's how we know f of -1 exists. Okay, let's continue to look at f. Then we're going to try the right side. Okay, so now we're going to substitute in -1 for x. So on the left side, we're going to have -1 squared plus 4 times -1 plus 5 equals 2. And I'm going to put a question mark because we don't know this yet. We're going to have -1, right side, x -1 plus 3. The right side, -1 plus 3, that's going to be 2. The left side, -1 squared is 1, minus 4 plus 5. 1 minus 4 is going to be -3 plus 5 equals 2. 2 equals 2. Therefore, limit as x approaches -1 of f of x exists and equals 2. And also we know that f of -1 exists and equals 2. F of -1 equals 2. And since these two are equal to each other, therefore, we'll say f of x is continuous. Okay, so we have test for continuity. Now we go over here to test for differentiability, and that's going to be the limit as x approaches -1 of not f of x, but f prime of x. -1 from the left side is equal to limit as x approaches -1 from the right side of f prime of x. And now I'm just going to differentiating the left side. We're going to have x squared becomes 2x, and plus 4x is just plus 4. And differentiating on the right side, we just have the derivative of x plus 3 is 1. Now substituting in -1, 2 times -1 plus 4 is equal to 1. -2 plus 4 is 2 is equal to 1. Is that a true statement? No. Okay, since limit as x approaches -1 of f prime of x does not exist, f of x is not differentiable at x equals -1. And so I really had this worked out quite well from Alondra, Elizabeth, and Brianna. I thought I got a right answer. Brenda, she insisted on being a stinker. She actually got it right because Brenda just worked out this side here, proved that the function was not differentiable. But if she had found out that it was differentiable, she would have actually been wrong because she wouldn't have checked continuity first. So she would have had to say, I don't know, and then check continuity. So Brenda needs to be careful. All right. You all need to be careful. All right, 8a. Write the equation of line tangent to the graph of f of x equals 4 over x cubed plus 2 at x equals -1. Well, what I'm going to do first is rewrite this f of x. We'll write this f of x is equal to 4x to the -3 power plus 2. And really organizing wise, let's see, we need to have a point. We'd like to get that point first. Our point, our x value is going to be -1. We need to find our y value, and we need to find our slope. So we have our x value. We want to find f of -1. So f of -1 is equal to 4 over -1 cubed plus 2. Well, -1 cubed is -1, so we're going to equal, and 4 over -1 is going to be -4 plus 2 equals -2. So our point is going to be -1 comma -2. And now for our slope. Okay, we have f of x written here. Let's find f prime of x, and f prime of x is going to be -3 times 4 x to the -4 power. And that's going to be equal to -12 over x to the 4th power. And f prime of -1 is going to be equal to -12 over -1 to the 4th power, which equals -12 over 1, which equals -12, and that's m of t. So our slope is going to be m of t, which is our slope, is equal to -12. It doesn't give units, so we'll just say -12, -12 meters per second. We don't know what it is. But -12 will suffice for now. Now to write the equation of the line, and we had one student who did this, found the point and the slope, but didn't continue and write the equation of the line. And we have to have that equation of the tangent line to do part B. So anyway, the equation of the line is going to be y minus y sub 1, which is going to be plus 2, is equal to our slope times x minus x sub 1, and minus -1 is going to be plus 1. So this is going to be, this is going to be our slope formula. All right, next, part B. Use the equation of the tangent line to approximate the value of f of negative 1.1. Well, first of all, I'm going to take this y plus 2 and set this equal to negative 12x, and negative 12 plus 1 is going to be negative 12, and subtracting 2, we're going to have y equals negative 12x minus 14. And we're going to find the value of f of negative 1.1, so what I'm going to do is write y of negative 1.1 equals negative 12 times negative 1.1 minus 14. Well, negative 12, negative times a negative is positive, so, and 12 times negative 1.1, that's going to be 13.2. And 13.2 minus 14 is equal to negative 0.8. So negative 0.8 should be a correct answer. I think I had Alondra and Elizabeth kind of start this out right and get it wrong in the arithmetic at the end. Okay. Now problem 9. A particle moves along the x-axis with the position given by a function x of t equals t cubed minus 6t squared plus 1 for t is greater than or equal to 0. The position is given in meters and time in seconds. Kind of a typical free response type problem. Determine the velocity of the particle at t seconds. Well, the velocity equation is going to be v of t is going to be the first derivative of the position, so x prime of t, which equals, finding the derivative, 3t squared minus 12t. And at t equals 2 seconds, we're going to find x prime of 2 equals 3 times 2 squared minus 12 times 2, and 3 times 2 squared is going to be 3 times 4, which is 12, minus 24, which equals negative 12 meters per second. Okay, now determine when the particle moves right, justify your answer. Well, to do that, what we're going to do is set our derivative function, first derivative function equals 0. So instead of having x prime of t, we're going to say 0 equals 3t squared minus 12t. And we have a common factor of 3t times t minus 4. So t is equal to 0, t is equal to 4. These times are when the particle will be at rest. So now we make a number line to test, see what's going on. We have x prime of t, our velocity on top, and our position x of t below, and our critical number here is 4. Now a particle's at rest at 0 also, but we're not interested to the left of 0. So anyway, at 4, we've already determined, plugging in 2, that the velocity is going to be negative. And so we have the particle going to the left from 0 to 4, and at time equals greater than 4, we can use 5. Well, we'll use this particle here, 3t times quantity t minus 4. We plug in 5, well, 3 times 5 is positive, 5 minus 4, positive, positive times positive, positive, and so our function is moving to the right. So determine when the particle is moving to the right. We will say when t is greater than 4 seconds, because on the interval from 4 to infinity, greater than 4, x prime of t is positive. Okay, so that's the justification. A lot of people, some people got that right. Most people got problem A right, so we box in this part B. Okay, part C. Determine the acceleration of the particle at t equals 2 seconds. Well, the acceleration, which we call a of t, is going to be the second derivative, which we call x double prime of t, of the position function. And we take the second derivative, we're going to take this 3t squared, which is the derivative of that's going to be 6t minus 12. And we're going to find it 2 seconds. So x double prime of 2 is going to be equal 6 times 2 minus 12, which equals 12 minus 12, which equals 0 meters. Oops. 0 meters per second squared. A lot of people got this one right. Yeah. Now D, is the particle speeding up or slowing down at t equals 2 seconds? Justify your answer. Well, we have to find what acceleration is doing. And to do that, we're going to make a second number line kind of right below the first. And here we're going to have x double prime of t, which is acceleration, over x of t. And we found out that the particle is at rest at 2 seconds. So our critical number here is going to be 2 seconds. And then to the left of that, we're going to need to plug in a number less than 2 seconds. So we come up here, and if we plug in 1, 6 times 1, that's going to be 6 minus 12. So acceleration is negative. So that's going to be concave down. And then to the right of 2, we can plug in 3. 6 times 3 is 18 minus 12. 18 minus 12 is 6. It's positive. So acceleration is positive from 2 to less than infinity. So we have concave up. Now the question is, particle speeding up or slowing down at t equals 2 seconds? Justify your answer. Well, here at 2 seconds, we need to have, for particle to be speeding up, acceleration and velocity signs have to be the same. Well, here we have at t equals 2 seconds, we have negative velocity, but our acceleration is 0. So the signs are not the same. So our correct answer to this question, or to what we're being asked to do here, is going to be neither. And why is that? Because our acceleration, x double prime of t, equals 0 at t equals 2 seconds. I had 3 people get this right, and X and Alex were the ones who got this right and justified correctly. Elizabeth also got it right, but her justification was not right. Okay, 10, a basic integration problem. We've been doing this since the beginning. I don't know if I had anybody get this right. I want you to get in the habit of analyzing this, and the way to do this is just make a sketch of the graph. Okay, I'm going to do this right here. We have a y-axis and an x-axis here, and we're going to go between 0 and 3. So on x we go from 0 to 3, and y we're going to have to go up higher. 3, 4, 5, 6, 7, 8, 9. And so here's y, x, and our function is going to be 3x. So that's going to be a rise over run of 3 over 1. So up 3 over 1, up 3 over 1, up 3 over 1. So we have this type of line going like this, and we're interested in the area below. So at 3, we draw a little vertical line segment here, and at 1, a vertical line segment. What we have is the area of this trapezoid. Okay, and for a trapezoid, the area is equal to 1/2 of the base 1 plus base 2 times the height of the trapezoid. Well, the height is equal to 2. Your base 1 is equal to 3, so B1 is 3, and base 2 is equal to 9. So our area is going to be 1/2 of base 1, which is 3, base 2 is 9, times our height, which is 2, and the 2 over 2 cancel, so we have 3 plus 9, so our area is 12 units squared. I don't know if I had anybody get this one right. I want you to get in the habit of making a little sketch to figure things out and get more things right. Anyway, that's our review of the test. I didn't have anybody knock it out of the park, but I saw good things from most everybody. So I encourage you to keep studying, especially those problems 1 through 6. We can't have people missing those.